So let's take a look at a probability question from the 2012 Leaving Cert Ordinary Level Paper 2. So we're looking at question 1, and this question is about two students at the door of a school guessing whether the next students in through the door are going to be boys or girls. So the question says that Peter and Neve go to a large school. One morning they arrive early. While they're waiting, they decide to guess whether each of the next three students to come in the door will be a boy or a girl. Write out the sample space showing all the possible outcomes. For example, BGG is one outcome representing boy, girl, girl. So a sample space, first of all, is just where we list all the outcomes of an event, and this can be done through visual representation. We can have a tree diagram, or we can have a two-way table, or we can just list out all the possible outcomes. And when we list out all the outcomes, that's called a systematic listing. So here we're just going to list out what are all the outcomes for three students walking through the door in the school. So they could be boy, 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 girl, boy, girl, boy, girl, boy, 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 girl, 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 boy, girl, 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 boy, or girl, girl, girl. So this is all the possible outcomes of three students walking through the door of the school. Peter says that these outcomes are equally likely, and Neve says they are not. What do we need to know about the students in the school to decide which of them is correct? So what Peter is saying is that it's equally likely that the next three students through the school will be a boy, 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 as it will be that they'll be a girl, girl, girl. So what we'll need to know in this question is we'll need to know if there's an equal number of boys as there is girls in the particular school. If there is the same number of boys as girls in the school, well then it's equally likely that the next three students would be boy, 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 as it would be girl, 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 as it would be to get any of the other of the outcomes. If it was a school, however, where there were far more boys than girls, so for example, if there was 900 boys and if there was 100 girls, well then clearly it's far more likely that the next three students through the door will be boy, 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 than it would be girl, girl, girl. So the number of boys and the number of girls is crucial in deciding whether these outcomes are equally likely. Part C of the question asks, if all the outcomes are equally likely, what's the probability that the three students will be two girls followed by a boy? So we've established that there's 8 possible outcomes altogether. And so the question is, of those 8 outcomes, how many are 2 girls followed by a boy? And we can see that 1 out of the 8 outcomes is 2 girls followed by a boy. When we're doing probability questions, it's good to remember that probability is the number of desirable outcomes over the total number of possible outcomes. So again, desirable outcome in this case is 2 girls and a boy, so 1, and the total number of possible outcomes is 8. And so the answer to this question is 1 out of 8. There is an alternate method to do this question. So if we want to know the probability that we have a girl followed by another girl followed by a boy, well, we multiply each of these individual probabilities. So the first student through the door, what's the probability that it's a girl? Well, if the events are equally likely, the probability it's a girl is 1 out of 2. The second student through the door, what's the probability that that's a girl? Well, it's still 1 out of 2. And then the third student through the door, what's the probability that that's a boy? Well, that's also 1 out of 2. So we're interested in the probability that it's a girl and another girl and a boy, and in probability and generally means to multiply. So if we multiply these probabilities together, we get 1 out of 8. So the final question, Neve guesses that there will be at least 1 girl among the next 3 students. Peter guesses that the next 3 students will be either 3 boys or 2 boys and a girl. Who is more likely to be correct, assuming all outcomes are equally likely? And so we're going to work out the probabilities of each of their guesses. So again, we're going to use the fact that the probability of event is equal to the number of desirable outcomes over the total number of possible outcomes. If we take Neve's guess, first of all, Neve has said that there will be at least 1 girl. So listing out all the possibilities, 7 of those possibilities include at least 1 girl. The only possibility or the only outcome that doesn't include a girl is the outcome where we have a boy, boy and boy. So the probability of at least 1 girl is 7 over 8, or 0.875, or 87.5%. So we can write the answer as a fraction, as a decimal, or as a percentage. If we take Peter's guess, well, Peter has said that it's either 3 boys or 2 boys and a girl. So again, if we write out all the outcomes, 8 possible outcomes, so Peter says either 3 boys, which is the first scenario here, or there's 3 cases of the 8 outcomes that are 2 boys and a girl in any order. So the probability of Peter's guess occurring, that it's 3 boys or 2 boys and a girl, well, that's going to be 4 out of 8, which is 0.5 or 50%. So because the question asks who is more likely to be correct, we have a look at which of the probabilities is greater, and Neve's is a higher probability, and so she is more likely to be correct.